Hello, everyone. Uh, can anyone of you make sure that my slides and my voice both are clear to you? Yeah. Thank you. Yeah. So I hope you guys are done with your exams. So may I know how many of you have given the exam for this course? Can I get a hand raise or thumbs up or something like that? Okay. You can also write in the chat box if you have taken the exam. I guess it was maybe yesterday or day before yesterday. I'm not sure. Our exams are tomorrow. Oh, okay. Oh, I thought it was on 23rd or 24th. Okay, all the best. How many of you have registered for the exam? Okay. Anyone else? Okay, no problem. So, as per the ritual which we do, we will wait for a few minutes so that more people can join, hoping that we'll get good number. And in the meanwhile, I would love to know about you guys, from where you are, what you guys are currently doing. So you can just drop in the chat box or you can unmute yourself if you're comfortable and tell me. Yeah. And as you know, my name is Imanshi Singh. I'm a PhD candidate at IIT Kanpur in BSV department. Yeah, so just drop from where you are, what you are doing in the chat box. Oh, nice, Vebani. So you are in a final year. So you are taking this course or you are auditing or crediting it because you are in a final year of chemical engineering. So I think this course is more of a basic undergraduate level course, but you are already in a final year. So any particular motive for taking this course? And other people also, please just drop your name, from where you are, what you guys are doing. As probably today is our last class, so let's communicate, right? So, yeah, anyone else wants to introduce themselves? You can just write in the chat box. There is no shyness there, and you guys will know who your colleagues are. Oh, nice, Weberly, very nice. You're doing chemical engineering from where? And oh, okay, nice. I hope you have learned something new in this course and it was fruitful for you. Other people also, please just drop in the chat box your name, from where you are, and what you guys are currently pursuing. Let's communicate a bit, right? It's good to communicate. We will know many things about others. Oh, okay. Okay. Can you elaborate, Rohan? And thank you for your kind introduction. Can you elaborate what are your duties? Okay. I'm glad, Vaibhavi, that you gained something from this course. Okay. Thank you, Venkatesan, for your kind introduction. So you guys have your exam tomorrow. I thought it has already taken place. Okay, nice. Then, okay, so Rohan, you're taking this course out of curiosity, I assume, right? Because you're already in the energy sector, and this course was pretty oriented towards just uh, getting to tell other people who are not associated with energy sector, to tell them what exactly things are there and what are their options. And as I can see that you're already working in the energy sector. Yeah. Okay. Okay. Nice. Yeah. So other people also, just as I can see, people have joined. Just quickly introduce yourself, your name, from where you are, and what you guys are currently doing. And then we'll get back to our setup. That is, we'll discuss one slide, and then we'll go back to some of the previous year questions, which help you in solving your current week assignment, as well as they might help you in your exam. Okay, thank you, Ashik, for your. I'm sorry if I'm pronouncing it wrong. Thank you for your kind introduction. Okay, you're doing BTech in civil engineering. Which year, may I know? We have very diverse audience, as you can see. People from all over the country has joined this course. So I hope this course was able to fulfill your expectations and you guys have learned something new from this course. Yeah. So I think we can start. In the meanwhile, everyone is free to just drop your introduction, your name, your place, and what you guys are currently doing. Right? So we will start. Yeah, we'll discuss, Weber, we'll discuss all this in the end of the lecture if we have time. If you could go and check back previous week's video, there were some discussions regarding it. You can refer to them, or else if we have time today, we'll also discuss. Okay, no problem in that. So let's begin with today's session. Yeah. So this is our last week live session, at least from my side. So let's hope that we'll communicate and we'll learn something new, right? So we will discuss today about one of the lectures which was part of this week. Can anyone confirm that they are able to see Professor Mandal's slide on my screen with the title of Cultivation of Algal Biomass and Treatment of Waste Water 2? Okay, I have received a positive feedback. So let's move on. So can anyone summarize me or brief me about what exactly is algal biomass or what is algae? Anyone, even a single line? It will help you in revisiting the lectures and remembering what you actually learned, right? So basically, what we're gonna discuss in this lecture is the cultivation of algal biomass and its treatment for producing, as you might remember from the consecutive lectures of this week, that we have generated bio oil, jet fuels, and all those things from the algal cultivation, right? So we'll see what we're gonna discuss in this. We're gonna basically cover last 3 points in this current lecture slide. So we'll discuss about the reactor system for cultivation or growth of microalgae, harvesting for the algal biomass, and treatment of wastewater using microalgae. I will show you two videos. One is of, I guess, 3 minutes, and another is of, I guess, 7 to 8 minutes, which will kind of brief you guys about the whole process, and it will make things bit real for you, because just reading theory about practical stuff is kind of difficult to visualize the real life image of things. So we'll quickly discuss this and then we'll go back to the videos, right? So I hope that you remember what is an LG or algae, as many people pronounce it. So algal biomass or algae, they are basically plant-like organisms, right? Because they are green, they can process their own food by using sunlight and CO2, right? So for cultivating them, there are multiple usage of microalgae. As you can see that we can generate bio oil, we can generate fuel from these things instead of because they randomly grow in our ponds, right? If there is a lot of contamination in the water, contamination with respect to if there's a lot of organic and inorganic material in the stagnant water, they grow very quickly. Even the closest example which I could have think of is if you guys have used coolers, right? Water coolers in your home. And if you're not cleaning the water regularly, there is a green layer of algae associated with your coolers or water bed of a cooler, right? And maybe in terrace or wherever there is a constant supply of water, the algae quickly grow there and they make the surface very slippery, right? So I hope this is pretty relatable to you guys. So for the growing of algae, there are basically majorly, we can say, two systems which we use at an industrial scale. One is the open system called the photobioreactor because it is directly in the presence of sunlight, right? The other one is a closed system, or of again it's a photobioreactor, but in this we supply light energy via the not directly via the sunlight, but by artificial tools or by regulating the sunlight itself, right? So in the picture here, you can see that it's a pond-like system in which the algae, this green color is basically the growth of algae, which is associated with the water, which is present as an open system, right? In the closed system, again, we'll see in the coming slides. I request everyone to kindly mute yourself until unless you want to ask any question, because this creates a little bit of disturbance for others also, as well as for me. Yeah, thank you. So what are the major types of closed photobioreactors? They are vertical tubular, horizontal tubular, plate, plastic bag systems, right? So from the name itself, we can guess what will be a vertical tubular. It will be a closed tube in vertical format, right? Same goes with a horizontal tubular, plate, and plastic bag type of system. So if we talk about closed photobioreactor, specifically of horizontal type, we can see here that this is the horizontal type of tubular bioreactor. These are the tubes in which the water will be circulated and the algae will be grown for cultivation purposes, right? Then it will be harvested, the algae will be extracted here, and it will be sent back for degassing, because if you remember from the lectures why we are degassing the system, can anyone give me the answer for this? And the hint is that algae, as I said, they are plant like, they uses sunlight and CO2 for producing biomass and other associated products. So there is one thing which is also produced when they are growing. Uh, okay, can other people uh, confirm whether I am clearly audible to you guys or not? Because someone is mentioning that my audio is not clear. Uh, okay. Uh, SM Sheikh, if the voice is still not clear to you, I will request you to please leave the meeting and rejoin again, or just check your connection once, because I guess it is okay for other people in the meeting. Yeah. And even if still not clear after doing this, kindly let me know. So, yeah, can anyone tell me why we were using the degassing stuff? Excuse me, degassing step in this process, related to a product, a gaseous product, which will be formed when we are cultivating green algae, which consume sunlight and CO2. Yeah, thank you everyone for telling me that my voice is clear. Um, Now, can anyone answer the question which I'm asking? Why the degassing step is being placed here? Why we need to degas the output from the horizontal tubular photobioreactor? Again, a bigger hint is that I'm saying algae are using sunlight and CO2 to produce biomass, and the products which we're going to talk about in later. And there is a gaseous product also. What is that gaseous product? We are using the degassing step for removing that gaseous product. Great, great, Venkatesan. It is oxygen, right? Because I said algae uses sunlight and CO2 to produce products, biomass, lipids, and all those stuff. And as a result, they produces oxygen. So before actually taking everything out from the bioreactor, we need to degas it, correct? So these are again some of the examples for the closed type of bioreactor. In this, it was a horizontal type of bioreactor. Here, it is a vertical column photobioreactor. As you can see, they are connected via thin tubes through which the feed and air and all those things are supplied to the algae which are being grown or cultivated in the vertical tubes. Here, this one is the flat panel bioreactor. And if you guys remember from the lecture, there is one spiral type of bioreactor also, in which the microalgae will be grown, right? So here I want to take a detour and want to share the videos for which I was talking. So let me know if my YouTube is visible to you guys. I hope my screen is visible. Uh, okay. And I'm gonna play it. You guys have to tell me whether it is clearly audible to you or not. Okay.
Algae Tech, securing fuel.
I hope the audio was there for you guys too. Okay, so we're gonna play this. It is basically how we use algae for biofuel. It is a very broad overview of the whole process. It is not at all directly related or directly uh, putting any one particular type of bio oil in the action. It is a very generic process and a generic overview of the whole process. Okay, so I'm gonna play it now.
Algae Tech, securing fuel independence sustainably. The world needs transport fuels. Diesel is used in cars, trucks, heavy machinery, and ships. Diesel is even used to generate electricity in remote mining projects and domestic peak top-up power stations. Jet fuel is needed to power aircraft for commercial transport. Both diesel and jet fuel are used extensively by the defense services. Existing global fossil fuel oil reserves are rapidly depleting. At current rates of consumption, the world uses 30 billion barrels of oil per annum. Sourcing this oil poses security and environmental challenges. As reserves decrease and consumption increases, prices will continue to rise. The alternative viable way to source oil is from industrial-scale, high-yield growth systems using algae. Algae uses the sun, carbon dioxide, and nutrients to grow. In a controlled environment, algae can multiply many times each day. Selected algae can produce 50% oil and 50% biomass, which converts to fuel products. This makes algae one of the world's most valuable, sustainable, and renewable fuel resources. Algae Tech has perfected an industrial-scale technology to grow algae for fuel. Algae Tech technology is based on the growing and harvesting of this valuable algae. The McConkey Strout technology uses 40-foot shipping containers, along with a solar source of light, to grow algae rapidly and profitably in a scalable and environmentally sustainable enclosed system. The Algae Tech solution has been recognized internationally for low water use. The ability to capture waste carbon dioxide feeds from industry and power stations, and the scalable modular design. A look inside the technology shows how light, carbon dioxide, and nutrients deliver a powerful algae growth mix in the controlled, enclosed photobioreactors. The resulting algae is made up of valuable oil, sugar, and protein biomass. The algae is separated into oil and biomass. These products are refined to produce biodiesel, jet fuel, and ethanol. Importantly, Algae Tech fuel has major cost advantages. It can be produced at approximately half the price of the current crude oil price. Algae Tech is in the business of delivering algae growth systems that offer cost-competitive, secure, high-quality fuels for transport and power. Algae Tech, secure.
So I hope this gave you a bit of real life idea about the whole process and how things are done. Secondly, I would like to bring your attention to a very unique feature of microalgae. If you remember during the video, they said that, or we know that algae requires carbon dioxide also, right, for growth here. So with this carbon dioxide, they are saying that we can use the carbon dioxide which is being released from the industries into the environment and the algae can use it, right? So the another application of microalgae first can be growing microalgae for the sole purpose of getting the products such as biofuels from them, right? The other can be mitigating the amount of CO2s from the environment, right? So there has been news in the recent, I guess, month only, maybe this month or maybe January. I'm not sure about it, but there are cyanobacterial filters which are situated in the middle of the cities, right? The cities which don't have enough space for trees to be planted there. So what that tree does is, it's not exactly a tree, it is basically a container. It's a photobioreactor which contains cyanobacteria, which is very useful in trapping the carbon dioxide from the environment, right? So it is highly efficient. It basically takes the carbon dioxide from the environment and converts it into a product. So there's an industry which plants these artificial trees in between the cities and high pollution areas to mitigate the release of CO2, or the CO2 which has already been released, by converting it into a useful product, right? So not only the microalgae or cyanobacteria or microorganisms are helpful in giving us the energy related products such as biofuels, but they are also helping in maintaining the environment, which is kind of sustainable to every single living organism, right? So this is another video. This one, I'm not going to play this because it is related to microalgae cultivation. But the aim of this video was to generate a very specific type of algae called spirulina. Spirulina is called as superfood. Why it is called as superfood? Because it is very high in protein. So if anyone knows a person who goes to a gym, or even to all the non-gym goers, and if they want to include some proteins, and majorly the proteins which are not descendant from the animal source, such as cow or other sources of protein, and they want plant-based proteins, spirulina provide such a great venue for them to experiment with protein intake. Again, spirulina is a algae, and this whole video describes how you basically cultivate the algae, then make the final product of spirulina pellets, or they are basically they are also found, can be found as powdered form and all those things. So I'm not going to play this because it was a bit off topic with respect to what we are discussing, but it is a part of microalgae cultivation, but not related to the biofuel production. Okay. So the other video which I want to discuss with you guys is this. It's a very uh, clean video about bioalgae cultivation and getting the biofuel at a very, very uh, less intensive environment, right? What I mean by less intensive environment, that you are not needing any big industries or things to get the oil biofuel from the algae. So it is a DIY video. So for those who don't know what is a DIY, DIY is basically do it yourself, which means you take the stuff which is near to you and you make a product out of it, right? So you are doing it yourself. Just follow the video. I'm not going to play the whole 10-minute video. There's a bit of I'll move forward after a certain time. I will provide the links for all the three videos from in my presentation, and you guys can check them later. Okay, so just hear this video and see this video.
You're lost in the forest with your
I hope the audio is still there for you guys. Can I get a yes or no for this? Anyone?
Yes.
Okay. Thank you so much.
camping gear, but no more fuel. You can't run your generator, your stove, or your lamp. What are you going to do? In a large-scale application, extracting biofuel from algae can be complicated, time-consuming, and expensive, but it's super handy to have when you're lost in the forest. Algae is comprised of three main components: carbohydrates, proteins, and lipids, or natural oils. Microalgae, in particular, has a high oil content and rapid biomass production, making it perfect for use in biofuel. So step number one was to collect some algae. I collected pond algae from a pond that I have near my house. Pond algae has the highest oil content, so I have to harvest less algae to get more biofuel. Step number two is going to be separating the oil from the algae. When algae grows, it absorbs sunlight and converts it to energy, and some of the energy is stored in the form of oil. In order to make biodiesel, we're going to need to separate the oil from the algae. Commercially, this is usually done by using high amounts of pressure or sound waves in order to crush the walls that hold in the oil within the algae. Instead, because we don't have that technology, we could either use a garlic press to actually physically squish the algae and remove the oil from it, or use a blender to break it down, and then once it settles, the oil will come to the top. I started out with a garlic press and it didn't go that well, so instead I'm going to use a blender to break it down. Since you're not going to have a blender in the wild, you can either use sticks and stones to squish down the algae or your hands to create a really mixed up, mushed solution, and then you can let it settle and the oil will settle to the top. So as your blended mixture is settling off to the side, you're now going to make what's called lye. Traditionally, sodium hydroxide is used to do a process called transesterification, which separates the mixture or the oil into glycerin and actual biodiesel, so it's usable. The problem is there's no way to get sodium hydroxide out in nature, so we're going to use the second best alternative, which is potassium hydroxide, which is commonly known as lye. Again, this is really hard to get in nature, but we're going to be able to make it using some gravel, some wood ashes, and some water. So in order to make your lye, you're going to start with a cup. This could be anything, a piece of cloth or anything you have, and I've punched some holes in the bottom. Then I'm going to add a little layer of gravel. This is going to stop the ashes from actually traveling through with the water. On top of the gravel, you're going to add some wood ashes. Hardwood is the best. Softwoods like pine is not usually going to produce the best product, but whatever you have in the forest is what you're going to be able to use. So I have a mason jar here. You could pour this into anything. I'm going to put it on top. And then I'm going to pour through some water. This is going to create lye water. Although it's not ideal because it's not a solid that you're going to mix into your oil, it's the best you're going to have. Again, the best to use is rainwater, not actual treated water, because it'll interfere less with the process. And now you're going to repeat this process of putting the water through the red cup into the mason jar multiple times, and that'll produce lye water, which you're going to use in the next transesterification process. So the final step of creating your awesome biodiesel is going to be to take the oil that you've separated out of the algae. You're going to take some of your wonderful lye water, which stands in for your potassium hydroxide. I've already poured some in there. And you're going to take alcohol. Usually they use methanol in the traditional commercial way of making biodiesel, but pretty much anything will stand in. I'm going to use rubbing alcohol. You could also use some wonderful drinking alcohol that you take along for the weekend, or you could use anything that's alcohol based out of your first aid kit. So I'm going to add some of this. Potassium hydroxide acts as a catalyst in the reaction, speeding it up. and it's going to separate glycerol from the methanol ester, which is the fancy name for biodiesel. So basically, you're going to be left with some great glycerol, which is like soap, and your biodiesel. You're going to separate the two, and then you can run your lamp, stove, and generator. So on the side here, you can see that we actually have the clear, chunky glycerol that's forming. And in the center, you have your biodiesel. So before we actually use our awesome biodiesel, we need to know exactly why it works. Here are temperatures, and that is how they found diesel. Next comes my favorite part of the project. It's when I get to play with fire. So I went to the local gas station and I picked up some dyed diesel. This is the regular stuff you would use in construction equipment or a diesel engine truck. As you can see, I put a fabric wick inside a small amount of diesel and lit it on fire. And the diesel is fueling the flame like it would in a kerosene lamp. The interesting part about diesel is that unlike gas, which combusts when exposed to a small amount of heat, which is the reason you can't have cigarettes or any sources of flame around a gas station, diesel requires a high heat, high pressure environment in order to combust, and this is why diesel engines are different than gas-powered engines. And we're going to use the burning diesel here as a reference to see how our biodiesel works compared to it. Here I have the exact same setup as before, except this time with our homemade biodiesel. Thinking back to the atomic structures we discussed before, both diesel and biodiesel have very similar structures, meaning that they should burn in similar ways. And they do, as you can see here, meaning that we have successfully made homemade biodiesel from algae.
So I hope that these two videos are interesting to you guys, because when I found them, it made science a bit more interesting for me. As you know, we don't need any big, expensive instruments or lab setups to do basic biology, right? So the whole process which we are discussing about bioreactors and biofuels and all that, there is a very basic chemistry behind everything, which can be easily done in our homes also, right? So anyone has any question till here? Or anyone want to comment on the videos which I have shown you guys? Because we're gonna move forward and we're gonna discuss about the differences between the open and closed photobioreactor. I hope all of you are awake. Okay, so should I move forward? I guess it's a yes from everyone. I hope so. Yeah, so now I hope now that you know what exactly is done for generating or getting the bio oil from the algae. There are some basic unit operations and steps in a very coordinated manner to get the oils from the algae, and they can be performed even at home and even in the industries where they are produced. The same unit operations are performed, but in a very elegant manner, right? So now we're going to discuss about the open and closed photobioreactors and some comparisons between them. So obviously they are pretty common to everyone. So if we talk about open pond bioreactors and closed photobioreactors, who will require more space, right? It's a very obvious choice. So open ponds will require more space because they will be widespread throughout the land in a form of open ponds, right? In closed bioreactors, if we have, for example, vertical type of photobioreactor, they will require less space in comparison to open pond bioreactors. Second parameter is water loss. So what, according to you, will face more water loss? Will it be open pond bioreactor or closed bioreactor? The answer is, again, it's very obvious that in open pond bioreactor, the water loss will be high because we are not controlling anything in the open ponds, right? The water loss due to evaporation will be done by the heat generated by the sunlight, right? In the closed bioreactor, we are modulating every parameter of the algal growth, hence the water loss will be less. Coming to CO2 loss, again, CO2 loss will be more in open ponds and very less in closed bioreactors. Oxygen concentration, what do you guys think? Will the oxygen concentration vary between open pond bioreactor and closed bioreactor, or will they be same? Anyone? We have discussed the degassing step also in the previous slide. So what according to you, what do you think? Open photobioreactor, closed photobioreactor, which one will have more concentration of oxygen? Anyone?
Madam, close to bioreactor, photoreactor,
Close.
yes.
Okay. And why no, none of you asked me why we need to remove oxygen? What was the reason we were removing oxygen? Because oxygen is good, right? And algae are not performing anaerobic respiration or things like that. Because for anaerobic processes, oxygen is not required, but algae are doing aerobic processes. So for aerobic processes, we need oxygen. So why are we removing oxygen? What is the reason?
During photosynthesis, CO2 only required and O2 is not required.
So if O2 is not required, we will remove it
Oh,
because it is not cause. If things are not causing any harm, why we are removing it? It means we are
yes.
adding a additional step of degassing, right? This mere addition of a unit operation for you guys should indicate that it is an important step. And why things are important? Things are important because first, either they are supporting in the process which we want, or they are adding to the benefit of the things which we want, or second, they are creating hindrance to the process or the product which we want, right? So what happens if you have a basic idea about the photosynthesis, and it was, I guess, discussed in class 10th biology, if I remember, that there is a photooxidative stress or damage associated with plants when they are exposed to excess oxygen when they are performing their regular photosynthesis, right? So oxygen is required for respiration. For photosynthesis, CO2 is required. But you cannot eliminate oxygen from the environment, and plant is there in the environment, right? So there is a very delicate system inside plants in which they make sure that where the photosynthesis is happening, the oxygen concentration is very low, right? They are maintaining very low oxygen concentration. But this cannot happen if the environment surrounding the plants is very rich in oxygen, right? Or the system within the plants is very rich in oxygen, and oxygen has no uh, pathway to pass. So in closed photobioreactors, what happens is that we need to intentionally remove oxygen. Otherwise, it will affect the photosynthesis, which is called photooxidative damage. And hence, if the photosynthesis is reduced, our whole product production will be less, right? Now about temperature. So what do you think, open bioreactors, open photobioreactors or closed photobioreactors, in which system maintaining temperature will be easy? Will it be open or closed? We want to, if you again remember, all the microorganisms as well as plants, animals, and even us, we need optimum temperature for our maximum growth or for our maximum performance, efficiency in this matter, we can say. So we perform best when we are in the optimum temperature. So one thing is the open pond, which is directly under the sunlight. Other is a closed system, which is being controlled for every parameter which is associated with the system. So temperature variation will be high in open or in close? Anyone want to answer this? You can give your response in the chat box also. I don't mind.
Variance is in highly in open pond, but we can control in closed photoreactor.
Yeah. So here temperature, here it means that the range through to which we can control temperature variation, right? So it will be better in closed photobioreactors in comparison to open pond bioreactors or open photobioreactors. What about shear? Shear is basically, it is a kind of mechanical stress which happens when we are mixing things, right? Because if you are mixing a solution, there are particles and we are providing force, right? We are giving it energy for agitation purposes. The particles will colloid with each other and they will generate friction, right? Friction will be generated. That kind of friction or force is called shear, or in stress terms it will be a shear stress. So in open ponds we do not vigorously move the water, hence the shear stress or shear is very low in comparison to close, where very high and fast mixing is done to assure that the growth is optimal. And why we are mixing in closed, anyone can give me a logic behind this, that why we are mixing in closed very vigorously or very high frequency of mixing, but in comparison to open? Because learning these properties are not going to benefit you, you should know the logic behind it. We can do vigorous, we do not lack in any kind of infrastructure in which we cannot agitate a open pond. If you can see this image closely, right? So there are turbines associated with it. These turbines are for what? These turbines are for mixing and assuring the circulation, right? The water should not be stagnant. So it's there. So there is not a technological bottleneck. So why we are not mixing greatly in open ponds, but we are greatly mixing it in closed photobioreactors? Any reason anyone can come up with? I'll give you guys some hint. In closed photobioreactors, every single parameter is under the control, right? So if there are, for example, let's take the example of vertical column photobioreactor. So this is a vertical column photobioreactor, and we are growing some algae here, and we are not agitating it, and we are providing CO2 and sunlight, right? So for example, if we are providing it a natural sunlight, the sun is here towards this side. Just imagine here, right? So gradually the sun gonna set, correct? Second, we are providing CO2. So if these columns are very high, right? For example, they are very large in size. They have like size in their feet, double digit feet size, right? So the algae which is growing at the bottom, because if you are providing gas here, chances are all the gas will be used by the algae which is found in this region, right? And the CO2 won't reach to the bottom algae, right? So that algae will not grow to the extent this part of the algae is growing due to the difference in the nutrients present within the single column. So if we are regularly agitating it, mixing it, so by this we are ensuring that all the nutrients, all the gas, and every single factors which are associated with the maximum growth of the algae is uniformly distributed throughout the reactor. Okay. In the open pond, why we are not doing it? Because the whole surface of the water or the reactor is directly exposed to the whole system equally. It is not like that this area is receiving less while this area is receiving more. No, right? Because this whole surface is exposed to the environment for the nutrients and the sunlight and every factor which is associated for the growth. But in closed system, this is one of the factor which we should keep in our mind while we are generating any reactor, not only photobioreactor, but any bioreactor in which microbes are used. Proper agitation or proper mixing of the system is assured so that the growth can be generated at its maximum. Okay, and you can found a hint here also that it is written is required for good mixing, pumping through gas exchange devices. This is the example through which it is done. But the reason was good mixing of the nutrients was required in the closed system. That is why we agitate more frequently in comparison to open ponds. Okay, I hope this is clear to you guys. Now coming to some other parameters which are associated. First one is cleaning. So I think this is self-explanatory in itself that in open ponds, not much of a trouble is there for cleaning purposes, but for closed pond, we require a lot of cleaning, right? So again, it's a very common parameter, but why we need more cleaning in closed bioreactor? We should always ask, we are reading or studying these properties, right? And we are knowing, okay, temperature is regulated, more regulated in the closed, but not in open. But why is this property affecting this change in behavior of open and closed? Right? So similarly for cleaning, why we are not cleaning or why we are not having trouble in cleaning open ponds in comparison to closed ponds or sorry, closed photobioreactors. Again, you don't need to put emphasis on photobioreactors. Most of these parameters are also associated with normal bioreactors. And from the intro, which I have got from the chat earlier, I guess most of you are from chemical engineering background. And I hope that you guys have covered bioreactors in your coursework, right? So these are the similar parameters and similar theory will be applied here also. Uh, by saying this, can anyone want to take a guess why we need more cleaning or specific cleaning methodologies are in place for closed photobioreactors, but not such things are there for open photobioreactors?
For light
Uh,
intensity, as indicated in that same image, if oils are aggregated with this microorganisms, so the enough light won't contact with all areas, won't go inside.
any other reason can you think of apart from what is written here? I'll give you a hint about see, we have limited nutrients, right? Because even these algae are growing on organic stuff, right? We need to provide them food, then only they will grow. So wherever there is food, right, that food is not only specific for algae, but any other type of microorganisms for which the conditions are suitable, they will grow, right? In other way or in other sense, what I'm trying to say is that contamination. If you're not properly cleaning a closed photobioreactor, the chances of contamination increase. And why we are scared of contamination? Not because that they will always be pathogenic, because at the end we are not using this product for food purposes, right? We're not going to eat it. So hence pathogenicity is out of guess from this point. The reason is if you have limited food supply for microalgae. But there is another microorganism in the bioreactor which is using your food, which you or food or nutrient which you supply for the microalgae growth. Hence, that food is not going to the microalgae, but that contamination or contaminator is using you're given food for multiplication purposes and it is increasing its in number. Hence, we do not need contamination. Therefore, we always assure that the closed photobioreactor is cleaned regularly and precise. Okay, again, this was the connecting point. Contamination risk. In this, it's low because we are assuring cleaning, right? And why contamination risk is high here? Because it is open. We have no control of what is getting in, what is getting grown in it, and at the end, how we are going to take out the contamination. Okay. Then biomass quality in open ponds, it is variable, while in closed photobioreactors, it is reproducible. Can anyone give me a reason why there is this discrepancy between open photobioreactor and closed photobioreactor regarding the biomass quality?
Madam, biomass quality we can't achieve in open pond because the parameters we can't control daily. If some days will be sunny, some days will be dull,
Yeah.
so that we can't reproduce the same quality in the everyday. And for closed bioreactor we can control, we can we can operate the closed bioreactor inside the room also by arranging the light setup and controlling the CO2 flow and other CO2 light
Yeah, great. So whenever
and
the
the
system
nutrient
is,
supply also.
yeah. So whenever the system is closed and under a strict regulation, the results are always reproducible, right? So even in research, if you have read research papers and some even review articles, there's always a mention of replications, right? So if you are getting a result in one set, before making any conclusions from this single set, we need to replicate our work and make inferences out of it to get to the final result or observation, right? Because if something is happening in first set, it doesn't mean that it will always happen. Chances there might be that in first set you have done something differently, right? While you were performing a protocol or while you were doing your experiment, you missed some step or you added something extra which was not in the protocol. But if you're doing replicates, your chances of error reduces, and hence from all these n number of inferences, you get a better observation and final result. Hence, whenever the system is closed and under strict regulatory conditions, the process will always be reproducible. That is the only reason that we can quantify, right? In your previous week's lecture, you have studied about the feedstock. You have studied about the amount of waste or organic waste which is required to generate this amount of, suppose, syngas, bio oil, biofuel, or all those products which we need. If we do not know what amount constitutes to what amount of product, then we won't be able to estimate the efficiency of a process, right? Hence, there will always be a reproducibility attached to a system which belongs to closed type or which is highly regulated. Okay. Then about biomass concentration, it is low, obviously, for the open ponds, and it is high with the closed photobioreactors because we are controlling all the parameters and we are making sure that our algae is living in a very optimum condition so that they can perform their maximum and they can grow to their maximum growth. Then production flexibility. So only few species are possible to be grown in open ponds because not all species are compatible with each other. While in closed photobioreactors, we can switch our cells, right? We in one day or 1 month, we are testing with one type of algae, and second, we are testing another type of algae. Hence, flexibility is more in closed photobioreactor in comparison to open photobioreactor. Process control and reproducibility, it is the same thing which I explained for the prior property, that it is very less in the open photobioreactor in comparison to closed photobioreactor. Okay. Now these are some important properties according to me when you are testing for a type of reactor which you want for your own work, right? For example, you're gonna grow microalgae and you want to generate biofuel. You do not want to use organic waste because a lot of unit operations was involved and it is very cost intensive for me. And you want to open a, or you basically you want to cultivate algae for products such as bio oil, right? Or you just want to, as we have discussed earlier, that you just want to reduce the concentration of carbon dioxide from the environment. So these are those important properties. So this is among tubular, this is for closed type photobioreactor only, but even in the closed photobioreactors, there were categories, right? So three are discussed here, that are tubular, column, and flat panel, right? So biomass yield is very, very high in tubular type of photobioreactor. The second highest is in flat panel photobioreactor, and the last or very low in column photobioreactor, right? It has to do again with the supply of nutrients and the way you are supplying these nutrients. Okay. The next one is exposed surface area for light illumination. It is maximum or highest in tubular photobioreactor, medium in flat panel bioreactor, and very low in column photobioreactor. Okay. Then manufacturing cost. Obviously, we need to keep this point in our mind when we are starting an industry, or we just want to have a basic idea about the input which will be required to cultivate algae, right? So the cost is very high or high in flat panel bioreactors, medium in column photobioreactor, and very low in tubular photobioreactor. Second, next, problem due to oxygen and CO2 accumulation. Why we are discussing this point here and have not discussed it here? Because here we were comparing open and closed one, right? Here, they all are closed one. So this problem is only associated with closed one. So this problem is maximum or highest in tubular photobioreactors, medium in flat panel bioreactors, and low in column bioreactor. Scale up possibility, that if you have a plant, and what are the chances that you can scale up your industry. So it is pretty easy or pretty easy in tubular photobioreactor. Okay, sorry for disturbing you guys again. Can other people send a yes or okay to me that they are still able to see my slide? Because some, I guess SM Sheikh is saying that he's not able to see my slide. So can someone tell me that both, again, you can just give me feedback that both my voice and my screens are audible and visible to you respectively. Okay, I have received one. Okay. Okay. SM Sheikh, I think you might be joining via your phone, or maybe there is some network issue with you. So as my screen is visible to most of you guys and I'm clearly audible, my recommendation will be same, that either switch your network or go to a place where you can get some good Wi-Fi, I guess. Otherwise, you can again rejoin the meeting after leaving it. Yeah. So I'll continue. Scale up possibility is maximum or highest in tubular type of photobioreactor, and second highest in uh, okay, essentially. And second is in column photobioreactor, and third or lowest is in flat panel bioreactor. And maintenance cost, as you can see, most of them have a low maintenance cost, but there is a cost associated with tubular photobioreactor. Okay, so these are some basic uh, dimensions of a photobioreactor. These are not hard-coded values. They can always be manipulated based upon the product and the area and the space you have for such. cultivation parks. Okay, so this is one type of dimension. So for open pond, you can have depth ranging from 1 to 15 centimeter. For horizontal tubular bioreactor, the internal diameter of a tube can be 2.5 centimeter. Vertical column photobioreactor, the internal diameter can be 2.6 centimeter. And for flat panel bioreactor, the width can be 3.2 centimeter. I'll show you flat panel bioreactor. Maybe I'll put a link while when I upload those links, because flat panel type of bioreactor, I think, is the bioreactor which I told you is being used as a artificial trees in the major cities. So it is a type of flat panel, but I have to cross check this. So I'll put a link in my site itself. Yeah, so we have cultivated it. We have grown our microalgae. We have selected that we want a open photobioreactor or a closed photobioreactor. After that, we need to harvest it, right? So what exactly harvesting is? Can anyone tell me what is harvesting? Anyone? Harvesting is a very generic term, right? It is associated with crops, that, and we also celebrate harvest season in multiple states. It is celebrated like on different occasions. Anyone? It's a very generic. It is not associated with waste to energy conversion. Harvest is a generic term. What is harvesting? Anyone? Okay. Well, okay. Either you guys do not want to answer, or because I know most of you guys must be knowing what is harvesting. Harvesting is just basically it's a process of uh, taking our produce, and here our produce or whatever we have cultivated is the microalgae, right? So we will take out the algal biomass now. We have increased the algal biomass, right? Now we are taking that out from the bioreactors or photobioreactors. So we have microalgal suspension, as you have seen in the video previously, which I've showed in the DIY video, right? That she collected the uh, microalgae from the pond directly, right? So what she did in that video, she mixed the uh, algae which she has extracted from the pond in the mixer grinder itself, right? But she has already removed some of the water from it, as you could have seen in the video. You can obviously go back to the video, that it was majorly the green part in the flask, which in the jar which she was taking, right? So we'll remove the water, and we'll perform some of the unit operations such as sedimentation, flocculation, and flotation. We'll discuss this in the coming slide, that what are these. So sedimentation, flocculation, and flotation. Then we will get some dry mass. When that mass reaches around 2 to 7% of the total weight, it is called as a concentrated biomass. Then this biomass, we subject it them for thickening, because we need the biomass only and nothing else, right? So for thickening process, what we do is centrifugation, ultrasonic agitation, and filtration. Again, if you remember from the video, that she mixed in the mixer, right? So that kind of thing is for bursting the algae, so that the oil can be released outside. So centrifugation, ultrasonic agitation, filtration, these are the processes which are associated with that step. Okay. So we will see what are the harvesting unit operations associated with algal biomass. So would you guys be kind enough to tell me what was flocculation?
The small particles will combine together. So it will form large
uh,
particle and it settle down.
and it will settle down. Why we need this process?
So by gravity settling itself, we can separate.
Hmm. But it will be very time consuming, right? Because it will depend upon the mass, if I'm correct, right? Gravitational sedimentation is a density dependent operation. So if you have bigger mass, they will settle quickly. But in flocculation, for example, we have microalgae, right? Those microalgae, they will settle, but they will require more time. So we add some agitator, not agitators, but we add some chemical flocculants. Here, flocculant means, as you clearly mentioned, that small particles combine each other to make bigger particles, which are easier for us to take out, right? So flocculation is used to aggregate the microalgae cells to increase the effective particle size. However, the cell wall is a bigger barrier to facilitate the extraction and the thickness of the cell wall is affected by the condition of the cell at the time of harvesting. So most commonly, alum and ferric chloride are chemical flocculants which are used while harvesting the microalgae. This method is often expensive in very large scale industries. So interrupting carbon dioxide supply to an algae system can cause microalgae to flocculate on its own, which is called autoflocculation. So if we are going in closed photobioreactor, we can interrupt the carbon dioxide supply because it is in our control, right? We can interrupt that and we can force the microalgae to form bigger particles, which in the end will help us in getting those microalgae out of the system, or the process is commonly known as harvesting, right? So flocculation is a process of harvesting the microalgae. So how we do it? So we basically, so basically flocculation is a process wherein colloids come out of suspension in the form of flock or flake, either spontaneously or due to the addition of a clarifying agent. Perikinetic flocculation refers to flocculation, contact or collision of a colloidal particle due to Brownian motion of colloidal particle, right? These things are pretty self-explanatory. That is why I'm not putting much time here, because things are literally written here. For me, there is nothing to explain. Okay, and even if you have questions, you know where to find me, right? I have linked my website in the first page of the site, which I will share with you guys. The second and other unit operations were flotation and sedimentation. So what is flotation? Usually flotation is used in combination with flocculation for algae during harvesting. So it is a simple method by which algae can be made to float on the surface medium and then removed. It is used, it used alum to flocculate algae air mixture with fine bubbles supplied by an air compressor. Sedimentation, as someone mentioned, that we use these processes to enhance the sedimentation process. So what is sedimentation? Can anyone tell me? I actually even briefly described in the previous slide.
Separating microorganism by using difference in density.
Yeah, correct. So it is a type of physical filtration, not filtration method, but physical method of separating things, right? Because we are using gravity as a force to separate based on the density. So the flocculation of algal biomass is generally followed by gravity sedimentation for settling of algal flocks. The sedimentation rates of algae are influenced by the settling velocity of the microalgae, which is increased by increasing cell dimension. And how we are increasing the cell dimension? By flocculating them, by making them come close together and make a big bulge or big volume of microalgae. Next step is the centrifugation. This is again a type of separation, right? In first, we are using gravity. In second, we are using the centrifugal force. So higher the mass, more will be the centrifugal force on it. So centrifugation is a method of separation algae by using a centrifuge to settling it into the bottom of the tank. This method may prove useful on a commercial industrial scale, but is expensive for personal use. The next one is the ultrasonic agitation. So why we are using ultrasonic agitation? Anyone? This is again it's a unit operation for making sure that they are getting big chunks so that the gravity can act on them. So due to ultrasonic agitation or ultrasound, what happens that these molecules or algae come together to make big balls of algae, which are greater in size. Hence, both centrifugation and gravity will work better on them. Next is the filtration. Again, it's a very generic process. You guys can go through the lecture as well as can go through the slides here. As we are kind of running out of time, we need to cover some questions also. So I'm skipping this part because these are again some basic methods and about the organisms which are here. These organisms are the ones which have been studied here, but there are still many microorganisms or especially algae which have tremendous potential and are being experimentally tested in at least at the laboratory scale, but not at the industrial scale. Okay, and this was some generic information about the treatment plants. Okay, so I think we should quickly run towards our questions. So I hope my slide is visible to you guys. So we'll quickly go to the questions as we always do. So my first question is, which of the following algae harvesting technique has highest TSS yield?
Here's what I found.
Can anyone answer me this? Though we have not discussed it, but I hope that you guys have gone through this week's lecture as you have your exam tomorrow. So I'm helping you in remembering things. Which of the following algae harvesting technique has the highest TSS? Flotation, centrifugation,
Polyelectrolytic fluctuation.
flocculation, or okay. Any other answers? You guys can type in the chat box your answers. Anyone want to attempt it? Okay, from next question onwards, I hope that we have more participants. So the correct answer is inorganic chemical flocculation. So don't worry if you were not able to remember the exact correct answer. If you remember, we have just surpassed this slide. If you go back to this slide, so this is the percentage yield or the TSS percentage. You can see these are the harvesting methods. And among them, the inorganic chemical flocculation is the highest. You don't need to remember the numbers, but you can just remember the highest and lowest, as I always say. So the highest is the inorganic chemical flocculation, and the lowest is either gravity sediment. Mostly it will be gravity sedimentation because it's a natural process and it will take more time, right? As we have discussed while we were discussing these properties. Okay. Next question is the compounds A and B in the following transesterification reaction are. So what is happening in this reaction? So we are mixing triglycerides with alcohol. So this process yields two products. What are these two products? Is it aldehyde and acetic acid? Is it ethers and glycerol? Is it esters and glycerol? Or it is esters and acetic acid?
Esters and
You
glycerol.
okay? I have one answer with me. Other people, you wanna you can send your answers in the chat box. Um, okay, I've got two answers till now. Other people, please also just try to attempt these questions. Your active participation means that you have understood and you are okay with the concepts and the questions are fine with you guys. And even if you are not understanding, don't worry, you have the lectures with you. You can quickly go through the lectures. These are not difficult ones, I hope. Okay, I started getting some answers. Okay, I have 4 answers by now. At least 50% of the participants can answer, right? So I need 1 to 2 more answers. Okay, anyone else want to try? Okay, well, obviously the answer is correct, as most of you are correct. The correct answer is esters and glycerol. If you do not remember, literally most of the stuff which was discussed in this particular lecture was about the whole process of trans-esterification. The trans-esterification process says that when you are mixing triglycerides with alcohol, they form esters and glycerol. And also we have seen the similar thing in the DIY video, right? Our next question is the order of reaction rate for esterification reaction is base catalyzed, enzyme catalyzed, acid catalyzed, or base catalyzed, acid catalyzed, enzyme catalyzed, acid catalyzed, and last base catalyzed, or is it enzyme catalyzed, base catalyzed, or and acid catalyzed? Even if you do not remember the correct answer, you can cut down the wrong options just by knowing a very basic property about enzymes, like why we use enzyme at the end of the day. I'm just giving you a hint. You can type your answers in the chat box. Anyone? Okay, I have received few answers. Other people also please join in giving answers, or even if those answers are wrong, don't worry about it. This is not your final exam. Okay, I guess I can tell you the answer. The answer is base catalyzed, acid catalyzed, and enzyme catalyzed. If you do not remember, you can go back to these slides and you can clearly see that the order of reaction, that is the first block here, the first characteristic property here, that the enzyme catalyzed is the lowest one while the base catalyzed is the highest one. If you do not know the reason for this, I will highly recommend you to go back to the lectures of this particular week because these properties are kind of important. Okay. Our next question is a picture-based question. So we need to complete this whole picture. So what exactly during the biooil production from the algal biomass, this A represents? What is the operation here, right? So is A is the extraction process or distillation, evaporation or filtration? Okay, I have received answer. Other people also, please try attempting these questions. Okay. Few more attempts. Uh, the answer is extraction. Yes, you guys are correct. So if you do not remember, you can see here that this operation was oil extraction part of the process when we were generating bio oil. Okay. Our next question is numerical based. And as you know, I'll give you 5 minutes for a numerical based question if it is a lengthy numerical. So you do not need to know any particular type of formula for this. You just need to know the molecular weights of the molecules which are present here, and you can directly use balancing and stoichiometric equations and the uh, variables which are given in the question. Okay, so just try to understand the question and then first write what is given, and then you can directly proceed towards the solution. Okay, so the question says bio oil extracted from an oilseed sample has 85% of triglycerides containing three long chains, which can produce methyl esters of lauric acid, myristic acid, and palmitic acid, for which their molecular formula is given in equal molecular ratio during process esterification using methanol and NaOH as a catalyst. Calculate the amount of biodiesel produced by the trans-esterification of 8 kg of bio oil. Assume efficiency of the conversion is 75% and 12% of palmitic acid is converted to soap. How much glycerol will be produced? Okay. I'll give you guys 5 minutes and your 5 minutes start now. 2 minutes left. I will highly motivate you guys to at least try attempt the question. You do not need to remember any particular formula here. So it's kind of easy type of question. So your 5 minutes are over. I have received few answers. Okay, great. Um, you guys can still send in your answers and then we will discuss the solution. Even if you get a nearby answer from the options which are available here, feel free to drop them in the chat box. The concepts needs to be clear. The calculation part, you can guys take care of it in the exams itself. So I think, okay. So the right answer is 0.650. That is the third option. And I guess most of you who have answered for this question, you guys are correct. I'm glad to see that. So as I mentioned, that you do not need any formula. You just need to know the molecular formula as well as the reaction mechanism, right? So transesterification, from the question itself, it says that transesterification produces methyl esters of lauric acid, myristic acid, palmitic acid, right? Hence, the produced methyl esters are these, which are already given. So the formula of the oil will be in the form of glycerol, right? It's a triglyceride base. So glycerol attached with these fatty acids or the acids which are given here, right? And the transesterification process is adding glycerides or triglycerides with alcohol to get glycerol and biodiesel compounds, right? So this is whatever is given to us and this is what we know. So we need to know the molecular weight of triglyceride. I hope that you know carbon is 12, hydrogen is 1, right? And all that stuff. So you can easily calculate the molecular weight. Then you can calculate the molecular weight of each fatty acid. Okay. And it is written that we have 8 kg of bio oil. So, and 85% 85% of triglyceride from the question, if you remember here. Oil seed sample has 85% triglyceride, right? So 85% of 8 kg will be 6.8 and the moles of triglycerides will be weight upon the total weight into 100, right? So it will be this. And if you calculate it correctly, you will get to 0.649, which can be easily approximated to 0.650, correct? So it was basically a problem related to the reaction mechanism, if you know it, and the molecular weight. Okay. And next question is a connected question from this previous question. So it says that what will be the amount of soap produced from the previous question. Again, you need to know the reaction and you need to know what exactly was a soap or the saponification reaction, which is called, which occurs when we are using triglycerides and alcohol. So again, I'll give you guys 5 minutes for this, and your 5 minutes starts now.
Madam, can you go back to previous slide, madam?
Yeah, sure, no problem. Just remember, in this, you want to know the amount of soap, okay? So I'll go back to the numerical question. Yeah, here is the question. I hope everyone has taken the quantities from here. I'll get back to the to our current question so that you guys can see the options here. So even if you have nearby answers with you, you can give that answer in the chat box. 1 minute remaining. Anyone who wants to send their answer can send it in the chat box. I guess we can see the answer as well as the solution. So Kudos to you guys who have got the right answer, and kudos to you to who tried attempting the question, right? Don't worry if you didn't get the right answer. So the solution is pretty easy, as you know, uh, that from the myristic acid and all the fatty acids which were given in the previous question, you can get the mass we have already calculated from the previous slide. The soap will be the remained commodity from that question. Hence, the reaction of the soap can be seen here. That if we are treating our triglyceride with NOH or basic alkali, we get soap and our alcohol back, right? So we have the formula of soap here, and again, you just need to get the mole fraction here. Sorry, not the mole fraction was asked, but you can get the amount. And even if the mole fraction was asked, you can easily calculate it based upon the molecular formula of the commodities. Okay. So our next question, again, it is a numerical based question. So I'll give you guys 5 minutes for this, but here a simple formula was used. So I'm just helping you out, guys, just by giving you the formula in case if you do not remember. So the question states that the 60 gram of a waste cooking oil was fully dissolved in some amount of neutralized ethanol by heating and titrated with N by 20 KOH solution using phenolphthalein indicator. If the titer value is 50 ml, determine the acid value of the oil, right? So if you know the variables which are present in the formula given below, you can easily get to the right answer. So you find, though it's a very short question, so I guess I'll restrict myself for giving you guys 3 minutes. And your 3 minutes starts now. One minute remaining. Those whoever wants to send their responses can send it in the chat box. So the time is up, and the correct answer is 2.337. And as I can see from the chat box, and I'm very happy to see that most of you are correct for this particular question. Obviously, it was a direct question. The challenge in the main exam will be to remember the formula at the right time, right? Here I have provided you guys with the formula. So I don't think that I need to discuss anything here. Everything is given and you just need to put it in the formula. Okay, and we'll go to our next question. And I promise this is the last numerical question of today. So this is what this question says, that a 250 ml bio-oil sample is reacted with 81 gram iodide monochloride. After reaction, Ki is added in it and the liberated iodine is titrated with sodium thiosulfate. If 0.22 moles of sodium thiosulfate is consumed to reach the titre value, determine the iodine value of the oil. Again, here you just need to know the molecular formulas of the components used in this and the reaction. And even if you do not know the reaction, if you just write what is reacting with what, you can logically guess the products and you can know the molecular weight. So I'll give you guys 5 minutes for this question, and your 5 minutes starts now. 2 minutes remaining. Even if your answers, again, I'm repeating myself, even if your answer is nearby to the options given, you can give the answer in the chat box. Don't worry about it. Even if it is wrong, we will see how it is solved. And chances are, if you're not getting the right answer, it can be that you might be doing some calculation mistakes. So, yeah, just try to attempt it. I guess we can discuss. I have received answers. Anyone else want to send their answer can directly type it in the chat box. So the correct answer is 14.16, right? So even if your answer was wrong, don't worry about it. So how are we gonna do it? As the question states that the ICL is reacting with Ki to give KCl and I2, right? This is the reaction. And also this I2 and Na2S2O3 are getting reacted to form NaI and Na2S4O6, correct? And the moles are given in the question itself. So from the above reaction and from the question, we can say that 0.22 moles of thiosulfate reacts with 0.11 mole of I2, right? So the molecular weight of iodine is 253.8. If you guys don't know, I will recommend you to know the molecular weights of some of the commonly used reagents and agents in the chemistry or specifically in the chemical engineering. It will actually save you a lot of effort. Okay, and also you will be able to attempt more questions, right? So we can directly get to the weight by multiplying the moles, right? And after this, we can see that 162.35 gram of ICL, again, this is the molecular weight of ICL, has 126.9 grams of iodine. And we know that 81 gram of iodide monochloride is present in the question. So 81 gram ICL has how many iodine molecules? How many gram of iodine, sorry, it will be having 63.31. Now, iodine used in the question, as given in the question, is 250 ml. So the remaining will be 35.39. Hence, the iodine value, or here we can say the value present in the oil will be this, or 14.156, which can be closely related to 14.16. So even in this question, it was not a difficult question. I guess most of you guys were not able to do it because you guys were not knowing the molecular weight. Again, the basic concept is there with about the moles, the amount and the volume. So I will again, in addition to the lectures, I will say that you guys can go back to the basic chemistry and know the concept of moles, molarity, right? It will help you in solving such questions in which actually there is no requirement of any formula. You can directly use these questions based upon your trivial knowledge about moles, weights, gram molecular weight, right? And all those basic chemistry. Cool. We'll go to our, I guess, second last question of today. It's a simple one-word answer type question, so we won't take more than 1 minute for this question. The magnitude of oxidation of biodiesel in presence of air and high temperature depends upon, is it the presence of saturated fatty acids, unsaturated fatty acid, aromatic compounds, or viscosity of the biodiesel? And if you do not know the answer, I can give you a hint here. If you know the difference between saturation and unsaturation, you can easily use that information and see what is more prone to oxidation. Is it the saturated compounds, unsaturated compounds, aromatic compounds, or the compounds which are highly viscous? Okay, I have one answer. Can I have more answers for this question? Because if you have taken previous classes, you actually do not need to remember the exact place where you have studied it. You can directly do it based upon your logic of understanding the difference between the saturation and saturation. Okay, I have received few answers. Well, the answer is the amount of unsaturation or the presence of unsaturation in the fatty acid. If you do not remember from where you have studied, it was part of this week's lecture where it was clearly said that the unsaturation in the fatty acid is responsible for the oxidation of the biodiesel. And again, if you do not remember this specifically from this context, you should know that and among the saturation and unsaturation, unsaturated fatty acids are always prone to more oxidation. Okay, because they have extra bond which can be oxidized. In saturation, there is no double bond, hence it is not prone to oxidation. Okay. Our last question is the density of biodiesel according to ASTM standard should be in the range of. So chances are that you might not remember the exact range, but it is good that if you are generating or if you are getting a bio oil or biofuel from algae or waste material, right? You should always try to match the properties of these biologically produced fuels to the standard fuels, right? So how you will know whether the product you have produced is of industrial importance? It will be based upon when you are comparing it with already known product. Okay. So oh great. I guess most of you guys remember it. I thought that you might not remember the exact range, but I'm glad to see that most of you are correct. Very nice. I don't remember numbers or range equally. So very good to see. Yeah. So obviously it is A option 0.84 to zero point 0.9 kg per liter is the density of biodiesel. And if you do not remember, you can refer back to the slides. I have put the screenshot where you can easily see it here also. That is 0.84 to 0.90. Right? So I guess these are all the questions from my side. And I would like to thank you all for being very patient with me throughout the course. And I hope that you guys were able to learn at least something, not completely, because I'm also learning with you guys. So I hope that you learned something and all the very best for your exam. I haven't put all the best here because I thought your exam was already done yesterday. I'm sorry for that. And feel free to reach out. Feel free to contact me. You know where to find me. And if you have any problems related to this coursework, you can always contact me. Uh, Ma'am, again, question 1 to 10 preview. I didn't get Hari. What you want to say? You want me to discuss all the questions again? The video will be provided to you, Hari. I will upload the video on my YouTube channel and the link will be provided to you by, yeah, I guess by today if I receive the link. I'll ask, because I have to get the link from other person. So I'll ask them to send me a link today itself so that I can upload it by today and you guys can review it. Repeat question, repeat once, question 10. Okay, we'll see what is question 10. Our 10th question is the density. If you do not remember this, you can go back to the lecture. I think this is the second lecture of week 8. There, Professor Mandal has discussed these properties and the qualities of biodiesel. Right? You can directly see that the density, the property is density, and the standard is from 0.84 to 0.9 kg per liter. Okay. Yeah. So I hope that this is fine with you guys, and I will try to upload the video by today because you guys have your exam tomorrow. So I'll try to upload it today, and even if I'm not able to upload it, please refer to the lecture slides of Professor Mandal. Even you can just go through the slide once before the exam. It will be helpful. And yeah, thank you so much. Thank you so much for being very patient with me. And from my side, that's all. You guys can leave if you want to go. Welcome, everyone. Vaibhavi, I cannot specifically say that what you should focus on. I can only, in this very last moment, I can only recommend you to just at least, because going through all the lectures is not a scope, but I will only suggest that at least go through all the slides and the points which we have discussed, because you will remember when you will going through the slides, okay, this was the point which we discussed in the live session, this was what discussed during the lectures, hence it is the important point. Okay, so that might help you. And I hope that you all do really good in your exam. Yes, Hari, I will try to upload the link by today evening. You can have the link from the YouTube channel. If you are accessing my lectures previously, then you know how to get the video. Okay? Yeah, no problem. Okay. Bye, everyone.